Hi guys, my name is Shubhang, chemistry master teacher at Vedantu. Now, we were talking about mole concept in the previous session. Yes, we covered some amazing tips and tricks, some amazing hacks, what to do, what not to do in order to solve mole concept questions, what are the traps to look out for, everything we discussed in and out in the previous session. Right? So let's continue this discussion ahead with our second session, and I'm sure you'll love the collection of problems this time as well. Let's begin, guys. So this is a comprehension type question in front of you. This is a typical problem that an industry faces when they try to concentrate any system. So what's happening here, guys? This is your process or a box. Let's just call it a box. This is where the devices are, the equipments are, which are separating or which are conducting this separation. Okay? What we see here is a typical mass balance exercise that is being done. We have feed stream, that is the input to the device, which is 25,000 kilogram per hour, and uska composition is given to us. Okay? Some water vapor is evaporating away. Some slurry means, generally slurry here means a solid paste. Okay? In this case, slurry is discarded. In this case, the slurry is waste. So the waste here contains NaCl, some NaOH, some water, and the concentrated NaOH solution is coming out of the box. So there's one thing that is going inside the box, the feed stream, and there are three outlets, one water vapor, one concentrated solution, and one slurry. This is a very simple question overall. It's a typical case of mass balance that happens on any device or any equipment in any and every industry. Now, how to approach such questions? What is asked? How much water is evaporated? How much concentrated solution is obtained? How much slurry is obtained? Okay. Now, the only thing that we know in terms of flow rate or feed rate or kg or moles is this. That's the feed stream. The answer to this question is a simple mass balance component wise. Okay, the answer to this question is simple mass balance component wise and nothing else. I'll show you how. Let's start approaching the first question. The first question says, how much water is evaporated per hour? So let's look, or let's find where all do we see water. We see some water coming here 50%. We see some water here 5%. And we see some water here as 80%. Okay. So if I want to apply mass balance on water, what will be my mass balance on water? The feed rate is 25,000 kg per hour. Uska 80% is water. So this much is the water ka flow rate or feed rate in kg per hour. This is equal to what? This is equal to the water in the concentrated solution plus the water in the vapor plus the water present in slurry. Now, in order to take this question ahead, we have been given data 5% weight here, 50% weight here, and obviously water vapor is 100% pure. But then I don't know the flow rates of slurry, the concentrated solution, the water vapor. So starting to solve the question from a component that is water, which is present in all four of them, is a mistake. Starting to solve a mass balance equation on a component which is present in multiple positions is a grave mistake, is going to cost you a lot of time in the exam. What you should start off with is a component which is present in the minimum places, in minimum streams. So let's take the solution to next slide, or let's first identify which stream or which component should we talk about. So water was present in all four of them. So I'm not interested in mass balancing on water in the beginning. Then we have NaOH and NaCl. NaOH is present in three streams. So not too much interested in NaOH. NaCl is present in only two streams. One the feed stream, one the slurry. Mass balance on NaCl should work, right? Because it's only present in one stream as inlet and one stream as outlet. Let's go ahead and then let's apply mass balance on NaCl. So in the beginning or the input, we have 25 kg per hour whose 18% is NaCl. This is equal to the flow rate of slurry Fs into how much is NaCl here? This is 90% NaCl. So that's into 0.9. So from here we can easily calculate the flow rate of slurry. What is the flow rate of slurry going to come out as? Let's cancel this here. So that's 250 into 18 upon 0.9. 0.9 I'm writing 9 by 10. So that's 2 to cancel, 500, 5000 kg per hour is the slurry flow rate. 5000 kg per hour is the slurry flow rate. I'll repeat what we did till now. It's a question based on mass balance. There's a device here which is concentrating NaOH solution. We have three components in the four streams that are going around here: water, NaCl and NaOH. Whenever we want to apply mass balance on more than one components, we should try to start from the position from the component which is present in minimum number of streams. Water is present in 4 stream, NaOH is present in 3 stream, NaCl is present in only 2 stream, the feed and the slurry. So we start the question by mass balancing on NaCl. 25,000 into 18% equal to, we don't know the flow rate, Fs into 90%. So from here we found the flow rate of slurry as 5,000. So our A part is done, our NaCl calculation is done. We have found out how much slurry was flowing. Now once you know the slurry ka flow rate, you know how much NaOH is coming here, right? Once you know the slurry ka flow rate, you know how much NaOH is coming here. So that is where our next part of the question starts, that now we need to, this was the answer, let me just tick it. So we have calculated on NaCl that was present in two streams. Now we talk about NaOH which is present in 3 streams. Mind you, I know the slurry flow rate now. The slurry flow rate now is 5000 kg per hour. So if I'm talking about NaOH pe mass balance, input NaOH is 25,000 into 2%. This is your input NaOH. Output NaOH, some NaOH is going away in slurry, 5000 into 5% of this value, and some NaOH is going where? In your concentrated solution. So flow rate of concentrated solution into 50%, 0.5. Let me not write it 0.5, let me write it 50 by 100. So NaOH input was here 25,000 of 2% of 25,000. Output 1 was here 5% of 5,000, and the other output is here concentrated NaOH solution. Fc is the flow rate I have considered. Uska 50% is your NaOH. Let's quickly solve these numbers. 100 easily seems to getting cancelled out everywhere. So numerate left side is now 50,000 equal to 100 had got cancelled. So that's 25,000 here plus Fc into 50. So that's 25,000 upon 50 equal to your flow rate of concentrated solution. How much this comes out to be? This comes out to be 500 kg per hour. So the concentrated solution that is coming out, guys, is 500 kg per hour. Very simple mass balance, but we have to be very careful of what we are doing. So now we know that the concentrated solution flowing here is 500 kg per hour. There is 5000 kg per hour flowing out here. So that's 5500 over, right? 5500 is over here, 25,000 I'm putting in here. So how much water is getting evaporated away? How much water is getting evaporated away? I'll repeat what I'm saying. Now I will not be solving for water again. Now I will use mass balance. Overall mass is always conserved. we were adding 25,000. We are removing 5,000 in the form of slurry. 50,000, 5,000 in the form of slurry. Then we are removing 500 in the form of concentrated NaOH solution. What is the rest? The rest is flow rate of water vapor. That's the fourth outlet. So 25,000 minus 5,000, that's 20,000. 20,000 minus 500, 19,500. The question here has been beautifully designed. The first part they have asked here is water ka flow rate, which we essentially end up calculating in the end. It is just not possible to find water flow rate in the beginning. So although it's a comprehension type question, there are three parts to it, but we end up deciding which part is to be solved first, not in this order necessarily. Important takeaway from this question: whenever we want to do mass balance on a multi-component system, we always choose the component first which is present in minimum number of streams or flow rates. Chaliye, I hope the question is clear to you guys. Let's go ahead. The question here says we have recent efforts to generate energy via cold fusion of deuterium atoms have centered on the remarkable ability of palladium to absorb as much as 120 times its own volume of deuterium gas at 180 m in 0 degrees Celsius. So what do you mean by cold fusion? We know that fission technology is generating electricity as nuclear power. Fission reaction takes place, breaking of nucleus. On the contrary, fusion reactions have the capability to generate even higher energies per gram of fuel used. So that's what they are talking about. Then he says it is possible because deuterium adsorbs a lot on palladium. How much deuterium adsorbs on palladium? The volume of deuterium adsorbed, ability of this to adsorb this deuterium gas. So volume of deuterium that gets adsorbed is 1120 times the volume of palladium metal that we use. That's a huge volume. Conditions are also given to us, that's at 180 m and 0 degrees Celsius. Next, the number of deuterium atoms per 10 atoms of palladium in a piece which is fully saturated is number of deuterium atoms per 10 atoms of palladium. So what he is asking us to find, number of deuterium atoms per 10 palladium atoms. This 10 is number of palladium atoms. He is asking what is this number, and we have only this relationship with us. Question looks very simple, is very simple, but just reaching till this point was the task. Now what to do? We need to convert these volume data into number data. How do we do that? For gases we can use PV equal to nRT. What to do for solids and liquids then? Shall I use PV equal to nRT? Pressure is known, temperature is known. For gases we can use PV equal to nRT, but for solids and liquids we have to go through density value. We cannot use PV equal to nRT, right? So let's start the question from there. Let's assume the volume of palladium that we are taking is A ml. Density of palladium is given to us. So what will be the weight of palladium? Density is equal to mass upon volume. So mass is equal to density into volume. So density is 11.8 gram per ml into the volume, that's A ml. So this is 11.8 A gram. So this much weight of palladium is present in A ml of palladium itself. Now we can convert this value to number of palladium atoms, yes or no? Easily we can do that. Weight can be converted to number of moles. Number of moles is equal to weight upon atomic weight. Atomic weight is 106.2. From here we can find the number of palladium atoms, that's number of moles, weight upon atomic weight into Avogadro. So this is the number of palladium atoms that we are looking at in the question. I repeat, I got this relation from the question. I said, let me choose volume of palladium to start as AML, and I converted the volume AML using density because it's a solid into weight to moles, and moles to number of particles. Now, the moment we said volume of palladium is AML, what do we also get? We get volume of deuterium as 1120 AML. What is the number of moles? 0 degree Celsius, 1 atm, that means 22400 se I can divide. 22400 se I can divide to convert it into number of moles. Yes or no? Absolutely correct. So that's 1 by 20 A or A by 20. Okay? The volume of deuterium that we got was 1120 times volume of palladium. We divided by 22400 to convert it into moles of deuterium. 0 cancel here, rest calculation done, so that you get A by 20. And how many particles are present therefore of deuterium? The particles that are present of deuterium is A by 20 into Avogadro. Okay? Now mind you, we were solving this for deuterium molecule everywhere. Okay? Let me go back to the question. Okay, we don't have to talk about deuterium molecule. He's talking about deuterium atom itself. Look, it seems like it. Chalo, koi baat nahi. Let's take the question ahead. So, we know that number of deuterium particles are A by 20 into Avogadro. Number of palladium particles are weight of palladium that we got as 11.8 A upon 106.2 Avogadro. Let me take this on next slide. Oops. Chalo, koi baat nahi. So we got number of deuterium molecule as A by 20 into Avogadro, and we got number of palladium particles as 11.8 A upon 106.2 into Avogadro. So if I divide how many deuterium particles are how many deuterium molecules are present for each palladium particle, then we'll have simply the division of these two. So that will convert to 1 by 20, 11.8 upon 106.2. So that's 1 by 20 here, 106.2 goes on the top, and you have 11.8 here. Let's see if we can resolve this conflict relatively easily. So this calculation converts to 5.31 upon 11.8. Okay. If you multiply 2 times, you get 10.6. So that's definitely not, this we can not calculate manually any further. It will take time to resolve this. But this is where we have landed, that number of deuterium particles per palladium particle is equal to 5.31 upon 11.8. What was the question talking about? Question was talking about per 10 palladium particles, right? So I'm putting 10 instead of number of palladium particles. So you can simply say multiplying this number by 10. So 5.31 upon 11.8 into 10. That's 53.1 upon 11.8. Now guys, this number is what? This number is for deuterium molecule. We need deuterium atom. So again, we'll multiply it by 2. So this is where the answer is moving ahead. 106.2 upon 11.8. This I think roughly 9 times should satisfy. Yeah, 106.2. This is 9. Overall, I wouldn't say a lengthy or a crazy level difficult question, but yes, a complicated one. Let me go back and let me cover the explanation one more time for you. The question says deuterium is to get adsorbed on palladium, and they give us this data to start off with. So we start solving the question with this data itself. We assume the volume of palladium to be A ml, so that we come to know the volume of deuterium as 1120 A. Now, because we assume the volume of palladium as A ml, we can convert it to weight using density and find number of palladium particles in terms of Avogadro number. We found volume of deuterium divided by 22400, we find moles of deuterium, and therefore we find particles of deuterium. What we are interested in the ratio of number of particles to the number of deuterium atoms. So when you take the ratio of number of deuterium to number of palladium atoms, you get your answer. Is this the answer that we are looking for, this calculation final? No, what we are looking for is number of deuterium atom per 10 palladium atom, This was for 1 palladium atom, so we multiply it by 10. Again, job not done. This was for deuterium molecule. We have to multiply it by 2 again to get deuterium atom. Okay? In gas phase, deuterium will be present as D2 deuterium molecule, but when it gets adsorbed on the solid, it will convert to atom. Same thing happens when we talk about hydrogen adsorption as well. H2 nickel, H2 palladium, remember? We have H2 gas used up, but it breaks down into hydrogen atom when it gets adsorbed. So, two behatareen questions taken, one based on mass balance, second based on simple adsorption calculations. Chalo, let's go ahead to the next question. Please read the question. I'll help you out then. Sample of SF5OF was contained in a glass vessel, okay, at 117 degrees Celsius and a pressure of 380 mmHg. ठीक है. Some amount of N2F4 was added. The final pressure became 160 mmHg. The reactions that occurred produced a variety of products. The yield of one particular product was 40% with respect to SF5OF reactant. Okay. All the SF5OF and N2F4 were consumed in the reaction. Nothing remains behind. What was the mass of so much produced if the volume of the vessel is 1.642 liter? Looks like a crazy complicated question. We have SFO5, SFOF, SF5OF, who was initially taken as 380 mm. We add N2F4 to it. We get lots of products. I would say lots of byproducts, plus my important product that we have to solve question on, SF5ONF2. This total ka pressure finally is 160 mm. Okay? N2F4, when we have added before reaction, it is not 160 mm. After reaction, it is 160 mm. How do we know that? By one reactant already was 380. If you add something, pressure should increase. Why is it decreasing? So it's decreasing because reactants have now converted to products. So products ka total pressure is 160. Now the question says the yield of SF5NONF2 is 40%. With respect to what? With respect to SF5OF, and that's mole percent. Okay, that's mole percent. So let's find moles of SF5NF2. Now the question looks doable. So the question is actually very simple. It's just that the language is very tricky. Moles here we can find using PV equal to nRT. 380 upon 760 is the pressure. Volume used is 1.642 upon R, that's 0.0821 because ATM liter was used, and temperature 117, that's 390. 270 plus 100 is 373 plus 17, 390. So from this we can find moles of SF5OF. Now the product that we are looking forward to, moles of SF5ONF2 is 40%. Look at the question, is 40 mole percent with respect to the reactant SF5OF. Yeah, so this is 40% of the value given. So 0.4 into this whole number, let me just write it as number of moles of SF5OF. You can do this calculation very easily. It's not a difficult one, not that difficult one. So now we know the moles of this compound. We can find the weight of this compound. Job done, question over. Moles multiplied by molecular weight, you will find the weight. That is what is asked. What was the mass of this produced in grams? So question is overall not difficult, guys. Question ka solving is also not at all difficult. The language is crazy tricky. It makes us think about other byproducts. We don't need them. 60% of your reactant is getting consumed there, so we don't need that data. Okay. In case they were talking about volume of the product formed, या फिर volume of this, या फिर the pressure of this, then we have to bring into the picture 160. Otherwise, till now we don't even have to bring in the picture of 160 mmHg. That is the final pressure in this. Simple and easy question, isn't it? Chalo, then let's go ahead. Next one. Again a very lengthy question. Why does sir keep giving so lengthy questions again and again? To analyze cast iron for its sulfur content, we took 6.4 gram sample. Okay? The iron in this 6.4 gram sample of iron was weighed out for analysis and treated as followed. It was first dissolved in HCl. So H2S gas evolved. Where did H2S come from? The sample had some iron sulfide in it from there. H2S came into the picture. H2S ko we converted into CDS. CDS ko we converted into CUS. CUS ko we converted into CuO. And here we have the data 0.795 gram is given to us. Calculate percentage of sulfur in the reactant. Again, we have multiple steps happening, multiple reactions happening. One way to solve is write every reaction, balance every step and then solve. Very lengthy, very tricky, prone to make a lot of mistakes. Second, let's try and apply POAC, principle of atomic conservation. Let's think from those lines. Whatever sulfur was present in your sample went ahead and gave H2S. Converted to CDS, then finally converted to CUS. That means if I can estimate how much moles of sulfur are present here, the same moles of sulfur are present in your reactant. Because sulfur was traveling ahead from FES to H2S, H2S to CDS, CDS to CUS. So till CUS the sulfur is maintained. Does the question say that every step is 100% efficient? No, but it does not say that it is not. It does not say that every step is not 100% efficient. So let's assume every step is 100% efficient and take the question ahead accordingly. Okay? So my target is what, guys? My target is to be able to find the moles of CUS. To be able to find the moles of CUS, that is the moles of sulfur at this point. Let's see how will we do it. Last reaction we'll have to solve. CUS plus O2 gives CuO plus SO2. To simplify calculations, let's multiply this with 2. So you have a 2 here, 4, 5, 6. So that's a 3 here. So from this logic we understand moles of CUS equal to moles of CuO. I am purposely not using POAC in the last step also. We could have done that. All the copper here is coming here. Right? From the reaction also we can see that moles of CUS is equal to moles of CuO. And because CuS contains 1 sulfur, this is equal to moles of sulfur in CuS. How will we find moles of cupric oxide? 0.795 is the weight upon atomic weight 63.5 plus 32. So from here you know moles of CuO, therefore you know moles of CuS, therefore you know moles of sulfur. Now this moles of sulfur, say we can find weight of sulfur, number of moles into 32. Where did this weight of sulfur come from? This sulfur came from the original iron sample. So this weight of sulfur is also present in your original iron sample. So weight of sulfur in your original iron sample divided by 6.4 gram, that's the weight of your sample which you considered, into 100 will give you what? Will give you the percentage that you're looking for, and answer will come out to be as 5. I repeat, it's a POAC question. It's a question in which we have to apply POAC 2 times. First, the sulfur is getting converted till CuS. So we apply POAC, principle of atomic conservation, on sulfur atoms. That is the number of atom of sulfur. The weight of sulfur element is constant in the reactant right till CuS. After that, all of CuS is converted into CuO. So we can simply say that using POAC, copper on copper this time, that moles of CuS is equal to moles of CuO. Or last step, you can also write the reaction. It's a simple one. So we understand that moles of CuO equal to moles of CuS. One CuS contains 1 sulfur atom, so that's equal to moles of sulfur as well. Once we know moles of sulfur, we know weight of sulfur. This weight of sulfur is present where? Is present in your iron sample, and so we divided by 6.4 the weight of sample taken to get the final answer. Lengthy question, right? But when you read in the exam, it scares the hell out of you because he's talking about multiple reactions happening. We might not know a reaction. So guys, I agree that advanced paper is difficult, but it's not that it's not meant to be solved. Look at the question, be patient, be calm, take few deep breaths, then approach rather than jumping in directly. Okay? So, POAC, what all we have covered till now? We covered first question on simple mass balance, right? We started from here, we covered a question on mass balance where we learned the logic that when you have multi-components and you have to balance mass, we balance mass on the component which is present in the least number of streams. Then we went ahead and we talked about adsorption, where the important point was how to relate the volume of a solid with the volume of gas on which it is getting adsorbed. We then went ahead and we talked about SF5OF question as well, where again the question looked very complicated. It looked as if we don't know enough reaction, but overall solving was very simple. We just had to consider 40% mole conversion of reactant to product. And just now we covered about POAC. POAC pe questions are generally asked in JEE Advanced because if you're not using POAC, you have to solve it in a long way. You waste a lot of time. So people who end up applying POAC save a lot of time in questions. Next one. When 10 ml of acetic acid is mixed with 40 ml of water, the final solution is found to have density. The percentage change in total volume on mixing is. Question is not difficult, huh, guys? Question is very simple. Let's solve. 10 ml of acetic acid. So volume of acetic acid taken is 10 ml. And what is the density given? 0.8. So we know the weight of acetic acid, density equal to mass upon volume. So that's 10 into 0.8 gram. So that's 8 gram sample. We are mixing it with water. Water we are using 40 ml. Density is 1. So that's 40 gram. So how much is the total? Weight total is equal to 48 gram. Right? फाइनल सॉल्यूशन का डेंसिटी और डेंसिटी टोटल इज गिवन टू अस 96/98 gram per ml. We know weight final, we know density final. So from here we can find volume. Density equal to mass upon volume. So volume equal to mass upon the density. So volume final becomes equal to weight upon the density, 96/98. We can simplify this easily. ml. 98/96 into 98. This is 2 times. This is your 49. So volume total comes out to be as 49 ml. If we just added, if the two components acted like an ideal solution, we would have just added the volume together. Yes or no? We expect the volume total to come out to be sum of the two volumes, that's 50 ml, but actually the volume is coming out as 49 ml. That means the solution is showing what? Positive deviation or negative deviation. Volume contraction is taking place. New attraction formed are stronger than the previous one. So this is the case of negative deviation of Raoult's law. So what did we do here? We found the final volume. Expected was 50. That means there is a volume contraction of 1 ml. Now, I chose this question to discuss today, guys, because of the way in which he is asking you to report the answer. We have to report the answer as A, B, C, D, where A is 1 if the volume has increased and it is 2 if the volume has decreased. We know that, we have seen here that the volume is decreasing, so A ka value is 2. Then he says BCD is the percentage change in volume. How much is the percentage change in volume? So we started off with 48 ml initially. Sorry, we started off with, 1 second guys, I think I'm lost a bit. 8 gram was here, 40 gram was here, so that's 48 gram in the beginning. Density is equal to mass upon volume, so volume is weight upon the density. No, everything looks correct. Volume comes as 49 ml. So what is the volume contraction that we are facing here? The volume contraction or the percentage change in volume. Percentage change in volume, is it 1 ml? No. Percentage change will be 1 upon 50 into 100. Volume contraction is 1 ml. But the percentage change with respect to theoretical value is 2%. That's the biggest catch in this question. That when we calculate change in volume, we get as 1, we report the answer as 2001. It is not 2001, it is 2002. The percentage change in volume means change in volume upon initial volume. So that's 2 and not 1. That's one catch in this question. The other catch in this question is BCD is, chalo, I understood that it is 2. So is BCD 2 or 002? Shall I report BCD as 002 or shall I report it as this? Obviously, we will report it as 002. Zeros put before any digit are of no value numerically. So that 002 is correct. So answer is 2002. Very simple question, guys, but two catches here. One, please be careful about what they are asking. Here they are not asking change in volume, they are asking percentage change in volume. Second, how to report an answer, it should be very, very clear to you. Okay, interesting question. Very high chances of such type of question coming in the exam where you have to report it in a different manner altogether. Chalo, I think that's the last question for the day. We have acetic acid which on chlorination yields trichloroacetic acid. So we have acetic acid which on chlorination yields trichloroacetic acid. He is asking what is the equivalent weight of the acetic acid. So molecular weight of acetic acid is how much? That's 60, isn't it? 2 oxygen 32, 32 plus 4, that's 36. 36 and 24, the molecular weight is 60 gram per mole. That means the question is we have to find n factor of acetic acid. N factor of acetic acid when it behaves as an acid is 1, but here it is not behaving as an acid, it is undergoing redox. When any species undergoes redox, n factor calculation comes from number of electrons exchanged. So we are supposed to find the change in oxidation state of the compound or all the atoms in acetic acid when it converts to trichloroacetic acid. So one part is fairly simple, guys, that we should not discuss about this much. It's common in the reactant and product, so no change in oxidation state. Let's talk about this carbon particularly. This carbon from the hydrogen side gets -3. This carbon from the CO2H side, because carbon is sp2 here, gets a +1. So that's -2 oxidation state. Carbon connected to 3 hydrogen, so -3. sp3 carbon connected to sp2 carbon, so +1. So total is -2. Let's talk about this case. Carbon from chlorines will get +3. Carbon from this sp2 carbon will get +1. So that's 4. What is the change in oxidation state? The change in oxidation state is 4 minus -2, that's 6. N factor in this question is 6. Equivalent weight is molecular weight upon N factor, and therefore the answer is 10. Brilliant, very interesting question, very simple question, SCQ type of question के लिए, but a very, very nice answer to it. Acetic acid, whenever we see, we generally mark N factor 1 because it's an acid, it loses 1 H plus. That is not the case here. N factor is reaction dependent. Here it's a redox reaction, so we have to calculate the change in number of electron per mole of acetic acid. When we did that, we found that carbon is going from -2 to +4 oxidation state, so the change in number of electrons is 6. Hence N factor is 6. The molecular weight equivalent weight equal to molecular weight upon N factor. Okay. Let me check if we have any more in store for you. Okay, we don't. So, thank you so much guys for joining, and this was the second session in mole concept. Now we'll keep posting or keep coming up with more sessions. Please do practice a lot. Please do a lot of brains while solving use a lot of brains while solving JEE Advanced question. Don't just start fighting with the questions instantly. Thank you guys. Take care. Bye-bye.